Hello everyone, welcome to another session of Patron. My name is Hector Angeles, and today I will guide you with a new part we are going to use. This workshop is number 4. We are going to call it mid-surface extraction example. So for this workshop, we need to import our files that we already made on SolidWorks. So we go import, and we're going to use these files that ends with X and T. So we are going to open the mid surface and need to specify that we got the mid surface from SolidWorks, and we use our Gbox to get that specific file. We open that, and then we hit OK. We must know our parameters. So in this case, we are going to use as material aluminum, and yeah, basically that material. So we are going to begin with this workshop. So for this, we're going to go for the 3D view. We can fit all, and then we are going to trim all the edges. Okay, so at this part in RHS window, we're going to change to edit, surface, trim, because we want to cut or some edges. So we are going to surface the trim. We need this, and the trimming edge, we got to hit this one and then apply. So this file is already trimmed, so we can continue to the next step. Next part is going to associate set edges to mid-surface surfaces. So we go to geometry, we need action, we go to associate, then curve method, we're going to use surface method. So we are going to select all the edges that we trimmed. So we go from this select this surface, and for surface list I'm going to choose this one and then apply. And we are going, as you can see, we have all the surface already associated, so we can continue looking for this workshop. The next part that we're going to make is to power mesh all the surfaces. So we need to go meshing. We must create mesh surface. We need to leave measure. We go to power, and we're going to use quad 4. Then we are going to uncheck this mark and change our value to 0.1875. Next step, we are going to select our surface list. We must select all the bodies with drawing box. So we must start from here. Then, so we have all our surface selected. Then apply. So it took a while, but all the meshes are created. So we're going to look for equivalence nodes. So we go back to mesh. Here the program has an error, so we need to go for verify element boundaries, and we must select 3 faces. This is the button from apply. We check And yeah, we have all the parts in yellow, so that means that indicates that we have 3 elements. Now that we have all things verified, I want to check it again. So verify element free apply. We must wait a little bit. So there you go. Then here we're going to change for the part that goes equivalences. Equivalence object all tolerance cube, and then we're going to hit apply button. This command see number database. Okay, so because I have a student edition, I cannot make this part, so we are going to skip it. Next, we are going to use our loads. So we are going to create, must be on total load, and select for element uniform. We're going to set a name for it. We are going to type total load, and we must here in target element type we must check for 2D, and then hit the button for input data. On edge load, we're going to type 0, 100, and again 0. We must correct this one so we cannot have problems, and then okay. Then we're going to hit the create the total load, so we must select application region. And for this part, so we are going to select edges. We go to this part that goes for edges, and we must select the top greatest in y-axis holes. That is this one, this one. We're going to add it. This one, the bottom ones, add, and we hit OK, then apply. As you can see, we have our forces. As you can see now, our forces are on the y-axis. We're going to change to the x-axis, and we want to go to the -x direction. So input data, we're going to change this one, put -100, hit OK, and then apply. Yeah, we want to override it because we don't want the other one. So apply. So we have a problem here. Let me correct it. Now we have our correct forces on the correct direction. So we change the load, and we select again the surfaces. So we have now the illustration, and then we're going here to create a displacement for nodal, and we're going to fix our box. Then select input data, translations. We don't want any. Hit OK button, and rotations also 0. And then we hit OK. Next, we're going to select our application region, and we're going to select Q or H, and Then we are going to select any hole on the base. So we're going to select this one, that one, and last but not least, this one. And then we are going to hit apply and apply. And we have our holes fixed. Then we are going to add materials. So we go to properties, isotropic, going to create isotropic manual input, material name, as we said at the beginning of the video, it's aluminum. And then we're going to hit input properties. Elastic modulus, in this case for aluminum, is to 6. And for percent ratio, you go for 0.3. Then hit OK. And apply. We can verify here existing materials. Now we have aluminum. Now we are going to create a shell. So we are going to properties, create 2D shell, and we're going to set the name as 2D shell. We must correct this. And then we're going to verify that we have homogeneous and standard formulation. Then we're going to select in our properties. Here we must select our material, aluminum, and OK. Something I forgot to mention, thickness is 1.25 inches. So hit OK. And under select member, we must then for select application ratio, select members, we're going to choose all or solid piece, the box, and we add it, hit OK, and then apply. Okay, it says okay, I'll define. So the next part we have all define, force, the load, and our hole at the base already fixed. We're going to analysis. Then we're going to select analyze entire model because that's how it's supposed to do. And for me, I'm going to go for analysis deck. If you have a complete version, you can go for a fault run. And job name, we're going to select as mid surface. Translation parameters, we don't need that because we are going to run the file on Nastran. So we must check in subcases. It's default, okay. So we don't need that anything. And default, okay. Cancel. And then we just apply. No element have been defined. Yes. Okay. So we make now again our power mesh, and we're going to try for our analysis. So we already set everything here, and we go to apply. The number database under. Okay. And then we go to Nastran. So we're going for Patron. This is for this job. And then we're going to select Nastran. we are now waiting to select our VDF file, then open, then run, and then we're going to wait for all the files to be selected. So we have a problem on this part on run the analysis because I have the student version, it didn't work at all. So we are going before Nastran, we must have an XDB file. So we go to access result, attach XDB results entity. We select results file. We select the mid surface with XDB, OK, and then apply. Then we're going to create deformation. So we're going to set default as A1 static subcase, this part, and select that one, and then apply. And then we're going to look at the results. Then go to display attributes, that is here. Then uncheck on the form and show title box. And then we hit apply. And then OK. And this must look like this. So we go on create, select French, this section, select stress tensor quantity on Mises, and then apply. Then we must look at display attributes, element edges, and uncheck the show title box, then apply. So these are our results. Thank you for watching. I hope you liked the video. Sorry for the issues. See you next one.